it, and they'll probably be very upset because it's a very tricky topic when you're in honors. So for regular geometry, all that you guys are expected to do for proofs is fill in the blanks. You will never be asked to create a proof from scratch for regular. They're going to have at least half of it filled in, and you're just clicking and dragging or writing in the correct answer. On the test, you guys will have like a little bank of options. You just have to tell me what goes in each blank. So you're not creating this from scratch. You just need to understand in general how things work when you guys are creating a proof. So let's take a look. Essentially what works with a proof is they're going to have it laid out. We're trying to go from A to B. They're going to give you some information, and with that you're trying to figure out why you would say this is then true. And you're just filling in the blanks. You're going step by step using the picture and definitions and things that we know to get from step A to step B. Right? So the first thing that we know is the given step, and that's actually the easiest part for a proof. The very first thing that you write is always whatever you see. Right? So step one is always A is parallel to B or whatever they gave you. And the reason for that is it was given. So when you guys are writing a proof, your first line should be easy peasy. Right? You just like rewrite whatever they gave you and then say, I know that because it was given to me. It's really easy. Alright, I'm trying to prove that angle 2 and angle 3 are congruent. We know that already, right? When we were practicing with parallel lines, these are alternate interior angles. We know that they're congruent. But that's a theorem. When we learned that in day 2, that's a theorem. So we need to prove a theorem is true before we can actually use it. So we've been using it without having proved it. So we're going to fix that to show why that would actually be true. So the next thing up is that 1 is congruent to 2. Can anybody tell me why angle 1 is congruent to angle 2? Because they're, yeah, what kind of angles are 1 and 2? They're corresponding. So the reason why we know they're congruent is because corresponding angles are congruent. Right? That's why we know that angle 1 and angle 2 are congruent. We've learned that already. If they're corresponding, they better be congruent. It's called a postulate. Why would angle 1 be congruent to angle 3? Take a look at your pictures. They're vertical, right? Everybody agrees that vertical angles are congruent, yes? So what would I write down for the reason that angle 1 is congruent to angle 3?
Angle 1 is vertical to... Oh, it's vertical angles.
Exactly, vertical angles are congruent. You just write vertical angles, or you abbreviate vertical angles are congruent. You don't have to be too detailed when you guys are giving the reason. Just tell me what kind of angles they are and what you know about them. So angle 1 and angle 3, based on the picture, which I've covered up, sorry, they're vertical, so they're congruent. Now, my last statement is that angle 2 and angle 3 are congruent. And the reason why we get this is by looking back up at the previous two statements. If I know that angle 1 is congruent to angle 2, but it's also congruent to angle 3, do you guys know what the property is? It says that angle 2 is congruent to angle 3. Do you guys know that property? You may not. If you don't, that's okay, I'll tell you, but does anybody know? If 1 is congruent to 2, but it's also congruent to 3, why can I say that 2 is congruent to 3? Syllogisms for words only. Yes?
Oh,
No, that's for words. Words only. It's not a theorem. It's algebraic, actually. It's an algebraic rule. No? Okay, it's called substitution. It's called substitution. I'm going to show you why it's called that. If I know that angle 1 is congruent to angle 2, and then I see another angle 1 right here, can't I swap out 1 for 2? I can substitute a 2 in for a 1 because I know that they're equal. That's what the substitution property tells you. If you see that these are the same, and then you see either one of those show up again, you can just swap out for the other one. So if I see 1 is equal to 2 and I see another 1, forget that, I know it's equal to 2, so I'm just going to plug that in. Substitution is another name for plugging in. So if I see another 1, I can plug in the 2 and that gives me this. So it's called the substitution property. If you can substitute something in for something else, substitution. That is almost always a step in a proof. Almost always, you don't always use it. But that is usually how you're going to conclude something like this. right? So that's a proof. They give you some information, you gotta tell me why based on the picture, and then you're good to go. Yes. Yes, remember that alternate interior angles being congruent is called the alternate interior angles theorem. And a theorem is always something that we need to prove to understand why it works. So that was just the proof on why we're actually allowed to say the alternate interior angles are congruent. All right. What if I switched it around? You guys see how I started with lines being parallel and then ended with 2 and 3 being congruent? I'm going to do the, well, official word. Nope. For words. What do you call it when you swap the ideas? Converse. Converse. We're going to prove the converse this time. We're going to switch the two ideas. We're going to start with the angles being congruent and then end with the lines being parallel. So we're going to do the kind of reverse of what we were doing before. So again, you always start with, for proof, what do you start with? Whatever they gave you. You literally just regurgitate whatever they have. So if we say that angle 2 is congruent to angle 3, that's what you write down. And then the reason for that is given. So your first step is always super easy. I know that because they gave it to me. Right. Why is angle 1 congruent to angle 3?
It's vertical.
Because vertical angles are congruent. Sorry, I have to stand kind of in front of the board so that the board doesn't glitch. Alright, why is angle 1 congruent to angle 2?
Corresponding.
Because corresponding angles are congruent. They were corresponding in the picture. So corresponding angles are congruent. Right, again, glance back at the picture. This picture tells you everything. Angle 1 and angle 2 are corresponding, which means that they have to be congruent. Now, based on the fact that corresponding angles are congruent, why would I know that the lines are parallel? Do you guys know how you would word that? Right now, in the proof, I know that I have corresponding angles being congruent. How would then I conclude that the lines are parallel?
Parallel lines are congruent.
Nope, parallel lines are actually not congruent. That is a false statement.
Oh.
How can I go from the fact that I have corresponding angles being congruent to then saying the lines are parallel?
It's 2 and 3.
Nope, 2 and 3 actually is not what we're going to use. You guys always use the last or last step or last 2 steps to prove to get to your conclusion. Okay, think what we did on lesson 3. If I said this is 50 and this is 50, you guys would have said yes, those are parallel, and then I would have asked you why. Well, you're going to basically say this again, but a little bit more. You're going to say lines are parallel because corresponding angles are congruent. Yes, you're just going to say lines are parallel. Whoa, stop moving. Because corresponding angles are congruent. The reason why you're not going to just repeat corresponding angles are congruent is because you're not specifying what we're trying to prove. So because we're trying to prove that the lines are parallel, you just make sure that you explain that in the reason. Oh, I know that this is happening because the lines are parallel when blah, blah, blah. So you do have to kind of be a little bit different when you're talking about lines versus angles, which is essentially the same reason. All right. So for proof, all of these are basically gotten from the picture. You're trying to see what's going on with the angles. This last one, you're trying to decide how do I use that information to make this conclusion. So the final step is usually the tricky one. So trying to wrap it all together with a tidy bow. But all the other steps are usually pretty straightforward. All right, we're just going to look at 2 more, and then there's one in the review we'll talk about as well. All right, so again, I have all of the left side filled out for you guys. You just have to tell me what's going on with the right side. How do I know that that's true? So why can I say that AB is parallel to EC? Because it's given. That's always the reason for your correspond.
Remember we're gonna get one point at least.
I'm sorry?
Remember we're gonna get at least one.
I mean, I wouldn't give you a whole lot of credit for just having given. That wouldn't probably be worth the whole point. All right, so I know that A, B, and EC are parallel. If you guys look at the picture, you'll have your highlighter for the test, right? So you're gonna be using that as a tool to help you. So those two lines are right here and right here. You guys see? A, B, and EC in the picture? You see that?
Wait.
A, B,
The way the letters are.
I know, so letters and the numbers are all mixed together, so that's why I'm showing you.
Where's D?
There's no D. There's no A, B, and E, C. Right? I know that those are parallel, so my next step is 1 and 2 are congruent. Why?
Because they're corresponding.
Yes, but how would you word that reason? Corresponding angles are congruent. Again, this is why it's so important you guys know what angle pairs look like. That's what we practiced on day 1, identifying angle pairs. You'll be able to see really quickly that angle 1 and angle 2 are corresponding.
Isn't 2 dashes?
Which ones?
3. 2 dashes.
What dashes? The symbol right here?
Yeah.
That's a symbol for parallel.
Oh.
All right, is everybody okay with step 1, step 2? Yes? All right, why is segment BC parallel to segment EF? That's given. I actually had 2 givens. The more information they give you, the better, actually. But they're going to separate them. They're never usually going to write both of the givens at the same time. They're going to separate them. So you have one given here and one given there. You use them one at a time. So now I know that if you guys want to use a different color or your same highlight or whatever, I now know that this is parallel to this. That's the second given. So why would angle 2 and angle 3 be congruent? Take a look at your picture. Now look at 2 and 3. 2 and 3 are not vertical. Are 2 and 3 a special angle relationship?
Yeah.
Which one? Corresponding. So what would the reason be for 2 and 3 being congruent? Corresponding angles are congruent.
Done this before. Unless we haven't taken
All right. So now, based on what we have now, how would I conclude that angle 1 is congruent to angle 3? Angle 1 and angle 3 do not have a relationship in the picture, so we can only use what we have in the proof.
Because angle 1 is equal to angle 2.
Yep.
And there's
So
2 and 3.
you're getting there.
Yeah.
Angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. So how can I conclude that angle 1 is congruent to angle 3? Substitution. You can take this 1 and put it in the place of that 2, because it's congruent to 2. So this would be a substitution. Does that make sense? If you have a number and you see it twice, you can swap out for what it's equal to. So if 1 is equal to 2, you can put that in the place of this 2 right here. Get a new expression. Is everybody with me so far?
Our question on test going to be like simple.
And you'll have all these little things that we're writing here. It's going to be in a little table. And you just have to figure out where each line goes. All right, here's our last one to practice. In my first step, I say that AB is parallel to DE. Why? It's given. All right, so I know that those two are parallel because it's given to me. Why would angle 1 be congruent to angle 4? So once you guys see that lines are parallel, one recommendation for proofs is once you guys see information, go ahead and put it into the picture. So because I know AB is parallel to DE, I'm going to highlight them, right like this. I also know that angle 1 and angle 2 are congruent, so I'm going to do this real quick, just in case I need to use it later. But why would I know that angle 1 is congruent to angle 4?
Because
Henry?
Because the lines are parallel.
Okay, that's not specific enough to tell me why 1 and 4 are congruent, though. You're going to use the fact that lines are parallel, yes, but why? Okay,
Alternate interior.
very good. We have a transversal right here. What does that make angle 1 and angle 4? They're alternate interior angles. You guys see that? Whenever you guys have parallel lines, you have to then use one of the angle pairs to make that conclusion. So when you're looking at the picture, angle 1 and angle 4, they make a Z. Remember that Z shape? When they make a Z, they're going to be congruent. So you're going to say alternate interior angles are congruent. This is a theorem. You can use a theorem within a proof. The proof that we did first was proving why it was true. Once you have proved that it's true, now you can use it within proofs. A theorem is a rule. Like if you're defining something, you know that's true by definition. But when you're trying to use a theorem, you have to first say why it's true, and then you can use it in other proofs. That's the definition of a theorem. Something you have to prove first. Great. So everybody with me on why 1 is congruent to 4? Using your alternate interior. Does everybody see that?
Wait, is that one line the transverse?
Yeah, the BD is a transversal. Yeah, you can't substitute anything because we don't have any previous lines in the step to use. Alright, why is 1 congruent to 2? It's given. That was in the given statement. Alright, so then based on what I have so far, why would 4 be congruent to 2? Four and 2 have no relationship in the picture. So I can't use the picture. Look at the other steps you have in the proof. Why would 4 be congruent to 2? Substitution. When there's no relationship in the picture, guys, it's usually a signal you need to go back within your proof to see what's happening. 1 is congruent to 4. Do you guys see 1 again? Yep, 1's right here. So 1 is congruent to 4 and congruent to 2. So I'm going to substitute the 4 in. Now I get the new statement. Okay? Look back at the picture. Why would 2 be congruent to 3? Because... Oh, no, but you don't say they're vertical. Vertical angles are congruent. Alright, that's how I know 2 is congruent to 3. How would I know 4 is congruent to 3? Any ideas? If you look at the picture, 4 and 3 don't have a relationship either, so why would I be able to conclude that? It's another substitution. You guys see why that's substitution?
No.
Right, 4 is congruent to 2. 2 is congruent to 3. So can I swap out this 2 for a 4? So I can take those middle 2 and kind of smush it. This is like a law of syllogism or transitive. If they have those 2 in common, the 2's, I can basically cancel them out and I just plug the 4 in for the 2 and I get this.
Well, are 4 and 3 like consecutive?
Yes, but they're only, consecutive angles are not congruent, by the way. Right?
Yeah.
And consecutive angles are supplementary, but for only when the lines are parallel. So if you look at the picture, the lines that 4 and 3 are consecutive within, these lines right here, are not parallel. So we wouldn't be able to make a relationship. So we're trying to say that they're congruent by using all the different angle relationships with the lines. Alright, so those are how proofs work, and the proofs that we're more concerned about, we're going to see next unit, which is where we're really going to be focusing on them. Those are with triangles. But there is one proof on the test. You need to make sure you know how to do these. But again, you'll have everything you need. You're going to have a little bank of options. You just got to tell me what goes in each spot within the proof. Okay? All right. Let me go ahead and wrap that up.
Oh, yeah.